Let's discuss about the frictional force. I will focus on the frictional force involving the calculations. But first, let's understand already what is a frictional force. Based on this definition, in short, a frictional force is a force that opposes the direction of motion. Ge lore an object is going in this direction. A frictional force it will be in the opposite direction, parallel to the surface. Ge lore an object is going upwards, a frictional force it will act in the opposite direction. And then another thing that is important an object is in contact with the surface. This is the surface, and then this object it's in contact with this surface. But let's say an object is hanged in this case. For the reason this object on the surface, this object I experience a frictional force. This is the surface, and then the object is in contact. So this is all about the frictional force. It's a force that opposes the direction of motion. But normally two types of frictional forces. Normally a static friction and then normally a kinetic friction. Are those forces. Based on the definition, a static friction is a force that opposes the motion of a stationary object relative to the surface. The word static means stationary. Let's say an object in this case, and then we'll try to push this object in this direction, but it happens this object is not moving. For the reason this object is not moving, what we call a static friction. The reason this object is not moving is because your force is less than the force this object. But as soon as your force increases, this object it will move. The moment this object it will move, it will now experience what we call the kinetic friction, because the word kinetic in a motion. Based on the definition, a kinetic friction is a force that opposes the motion of a moving object relative to the surface. The moment this object it will move, now experience a kinetic friction. Now this force is greater than the force this object, because now it will move. It's important to understand a kinetic friction is always less than the static friction. Let's say for example o pusha a car. O ka lemoga gore ge o thoma pusha this car initially, o apply a greater force, but the moment this object it thoma o tsamaya, ga o sa apply a lot of force, because now this object is in motion. E rela gore tlo apply a very small force, because now this object is in motion. E rela gore re na le a kinetic friction. So ka lemoga gore now re apply a force e nyane, unlike this object ge le stationary. And then remember gore ge le stationary re la gore re na le a static friction. So ge le stationary re apply a greater force, but the moment it thoma o tsamaya re apply a less force. So that is why the kinetic friction is less than the static friction. Re na le formula ya go calculate a static friction and a kinetic friction. E lekana le the coefficient of friction times a normal force. So the same as the kinetic. E lekana le the coefficient of friction times a normal force. But let's understand what is a coefficient of friction. Actually, coefficient of friction in order to experience what type of a friction. Let's say for example more na le two path. let's say more na le a smooth surface, and then this one is a rough surface. And then let's say remove an object here, and then remove an object here. For the reason ya gore more na le a smooth surface, e rela gore this object you gonna move very easy. So rela gore the frictional force for this object you ba small. But because this one is a rough surface, rela gore the frictional force you ba high. Because you can remove object on the smooth and then on the rough. Because this one is rough, rela gore you ba difficult or move this object. Therefore rela gore apply a lot of force. So that is why rela a rough surface, rela the friction you ba high, and then for this one rela you ba small. So actually coefficient of friction in order to experience what type of friction is directly proportional to the frictional force. The higher the coefficient of friction, the higher the frictional force. The smaller the coefficient of friction, the smaller the frictional force. So coefficient of friction it depends on the nature of the surface. Ge le gore re na le a rough surface, e rela gore the coefficient of friction you ba high, and then ge le gore re na le a smooth surface, e rela gore the coefficient of friction you ba small. So now I lebelle the calculations involving the frictional force. Let's see this one. A crate of mass 50 kg rests on a flat horizontal surface. The coefficient of static friction between the crate and the surface is 0.3. Determine the magnitude of the maximum force of static friction between the crate and the surface. This object is not moving because mobile file the coefficient of static friction. Re tseba gore ge re na le a static friction e rela gore the object is not moving. Re tseba gore a friction is always in the opposite direction. Object ya rena e in this direction because ka kgona bona gore force applied e in this direction. E rela gore the frictional force, which is the static, e rela gore yo ba in the opposite direction. But first ke nyaka gore re draw a free body diagram. Mo re na le an object. For the fact ya gore this object in a le mass, e rela gore you experience the gravity. And then more ba re bontšitše gore this object in this direction, rela gore this is our force applied. And then re tseba gore a normal force is always perpendicular to the surface. Ge e le gore this is our surface, e rela gore the normal force must be in this direction to form 90 degrees. So rela gore re na le a normal force that is upwards. And then re na le another force this time. Re na le a frictional force. Re tseba gore a frictional force always opposes the direction of motion. Object ya rena in this direction because ka kgona bona the force applied. So e rela gore the static friction it will be in the opposite direction. So rela gore more na le a frictional force that is in the opposite direction. So re bitša gore ke a static friction. So now re lebelle this question ya calculation. Determine the magnitude of the maximum force of static friction between the crate and the surface. Re tseba gore re na le a formula. It says the coefficient of friction times the normal force. Ba re file gore the coefficient of friction ke 0.3, but ga re ne a normal force. So rela gore re tlo tshwanela gore re kreye a normal force. For the reason ya gore this object is not going up or down, rela gore the upward and the downward forces are balanced. Re na le a normal force in this direction, and then re na le our weight force in this direction. So rela gore normal force e lekana le our weight force because this object ga e godimo ebile ga e fase. Rela gore the upward and the downward forces are balanced. So now I will say this is coefficient of friction times the normal force, which is mg, and then from there it's about substitution. Finally 0.3, and then mass 50 kilograms, and then gravity is 9.8. So our static friction is 147 newtons. So this actually means gore this object di kgone go move, e rela gore o tlo tshwanela gore o apply a force that is greater than 147, because the reason this object be push a low right move is because your force is less than this one. But as soon as you apply a greater force, you overcome this force, rela gore your object it will tsamaya, and then now rabale a kinetic friction. So anyway, this is our answer. I'll level the next one. This question here, a crate of mass 50 kilograms accelerates along the horizontal surface. The coefficient of kinetic friction between the crate and the surface is 0.1. While accelerating, a force of 100 newtons acts on the crate at an angle of 30 degrees to the horizontal. Mornally, an object is being pulled at an angle. Yeah, the previous one it was being pulled horizontally. So now I draw a free body diagram first. Mornally, an object, and then always a downward weight force, because this object in a mass mornally our gravity, which is downwards, and then arnally a normal force, because normal force always perpendicular to the surface. This is our surface, this must be a normal force. And then this object inally force applied to in this direction. So this is force applied. And then arnally a friction, because this object here in this direction, friction you are in the opposite direction. So mornally a friction. So this is our free body diagram. I level this question. Question area: determine the magnitude of the force of friction. Re tseba gore re nyaka go calculate kinetic friction, because ba file gore the coefficient of friction. So this is the same as saying coefficient of friction and then times the normal force. Re gore tlo tshwanela gore kry a normal force, because re only coefficient of friction. But what we know for as long as this object is not going up or down, upward and downward forces are balanced. And then because this object at an angle, you create the components. More robally a component is vertical, and then morally a component that is horizontal. But the upward forces, a normal force that is upward, and then FV, a weight force which is downwards. So for upward forces FV and then FN. So now Fn plus Fv Fg, because upward forces downward forces. From there nka find Fn kare Fg minus Fv. So let's find Fv first, because Fv re tlo shumisha a trig ratio. Re tseba gore sin theta opposite over hypotenuse. This is Fv and then over 100. So Fv sin theta times 100. So now because re na le fv re la gore ke tlo substitute here and then recalculator fn. So I will say fn e lekana le fg, remember le lekana le mg, and then minus fv re le ke sin theta times 100. So mass ke 50 and then gravity is 9.8 and then minus sin 30 degrees times 100. So it will fa gore ke 440 newtons. And then now because re na le a normal force re la gore re le gone calculate kinetic. So re na le coefficient of friction which is 0.1 and then normal force re kry-ile gore ke 440. So from there ya go fa gore ke 44 newtons. So this is our answer. O ka lemoga gore it's not difficult at all, more especially ge le gore o lebeletše a previous video, because on the previous video re be re determine how to find the normal force ge re na le this kind of situation. So this is our answer anyway. This one here, a force of 100 newtons pushes an object of mass 10 kilograms to the right at an angle of 60 degrees to the horizontal. The coefficient of kinetic friction between the box and the surface is 0.1. Determine the magnitude of the force of friction. Now our object is being pushed at an angle, unlike the previous one where it was being pulled. So first I draw here a free body diagram. More narly an object, and then narly a gravitational force which is always downwards, and then narly a normal force. Remember, normal force is always perpendicular to the surface. This object is being pushed downwards, but re a tseba gore yeah in this direction, just like when you're pushing a crate. So now because this object here in this direction re la gore re na le a friction e le gore e tlo acta in the opposite direction, so it means our friction over in this direction. And then this force applied gona bona gore yeah in this direction, so re la gore le rena re tlo ngwana in this way. This is force applied. Ke nyaka gore e move away from this point, is cover in this way. So ke tlo draw in this way. And then this is our free body diagram. So now our level this question. Question re determine the magnitude of the force of friction. First re ngwale a formula ya friction. And then now let's find the normal force. This force it creates a component here vertically downwards, because leona is being pushed downwards. And then from there gravity which is downwards. For the reason here this object is not going up or down, the upward forces and the downward forces are balanced. Therefore for upward fn fela, so fn le fg plus fv, because for downward forces fg and fv. So now let's find fv. Fv re tseba gore ro shumisha a trig ratio, and then just like the previous one ile sin theta times our force which is 100 newtons. So more mg plus sin theta times 100. And then now let's substitute. Rna mass wa 10 kilograms and then gravity 9.8, and then our angle ke 60 degrees and then times 100 re fa gore ke 184.60. So this is our normal force, and then now let's find the friction. Re na le 0.1 and then times 184.60. Therefore re la gore our friction e lekana le 18.46 newtons. So this is our kinetic friction. So that's it for this question.